Okay, this is another elevator problem, but instead, like, you don't have to just think of it as just elevator. So imagine that this is a rocket ship. But it's a really, really special rocket ship because it sucks and it's going down at an acceleration of 4 meters per second squared. And I want to know what is the astronaut inside. There's an astronaut inside. I want to know what his apparent weight is. So what is the apparent weight of said astronaut? Now, apparent weight, remember, that's just me basically saying what's the normal force going to be. So, when we look at this, we look at it based on our astronaut guy, right? Since the ship is accelerating downwards, so is our astronaut friend. So he's going to accelerate downward at 4 meters per second squared. And then we kind of just draw all the forces acting on our astronaut. There's the force of gravity pushing him down. Let's make this a little smaller. So the force of gravity pushing him down. The normal force, right, because he's in the ship, right, so there's a ground here. So because there's a ground here, there's going to be a normal force. So there's a normal force keeping him up. And then there's an acceleration. Now, the acceleration is not a force, but it's going to come in handy when we say that the net force net in the y direction, it's the mass times the acceleration in the y, which is this, is equal to the two forces acting on the y, which is a normal force, and the force of gravity, but the force of gravity is pointing down, and force of gravity is mass times gravity. His mass is, oh, I didn't give you the mass. Okay, so let's say the mass of the astronaut is, just so we keep it simple, the mass of the astronaut is 45 kilograms. Okay, so now we know the mass, because I gave it to you. So the mass is 45 kilograms times 9.81, which would make his force of gravity equal to 441.45 newtons. Kind of forgot what units we were talking about. Alright, so then his mass is 45 kilograms, right? Because I gave it to you. So that means if we go back to this equation, we have 45 times his acceleration, which is negative 4. It's negative 4 because it's pointing down, is equal to the normal force, which is what we're trying to find, minus 441.45 newtons. So then 45 times negative 4 is negative 180 newtons, is equal to Fn minus 441.45. We add 441.45 to both sides. So we get 261 newtons is equal to the normal force. This is his apparent weight. His real weight is his force of gravity. This is his weight. His real weight. Your weight is always force times gravity. That's always the weight. The weight is described as the force pushing down on you by whatever object you're on, in this case Earth. But his apparent weight is the answer we're looking for, so here we go. Done.